This is the first video for section 6.1. We're only covering one section in chapter 6, but there are several things that we'll need to talk about. And the first thing is to find out what is a random variable. And so we'll define that. And then we'll also see some different uses of the idea of discrete versus continuous. We learned these words in chapter 1, and they're still going to have a similar meaning, but it's going to be slightly different when we're talking about random variables. The main parts of this section that you're going to want to really focus on are the ways that probability connect to distributions. And so when we talk about a discrete random variable, that is a data set that we have, and we're then able to use probability to find out, what are the chances of having a certain outcome. So there are some things that you'll want to just know at an existence level, but most of it will either be supported, especially any of the calculations. You'll be able to use StatCrunch or your calculator. And so the supported material of being able to find the mean and standard deviation for a discrete random variable, those will be things that you can do with support, with technology. The other things that we'll talk about that you'll probably want to know either as an independent or lifetime. So I'm going to kind of draw an arrow here. One of these two is just the idea of this expected value. And just understanding that the expected value is contextual. It's what we expect as an outcome, but it's also just the mean. So the mean and the expected value are the same. They're calculated the same way. They are the same value, but we call it an expected value or an expected outcome because it's for the situation that we're dealing with, that's just in context, and we like our answers to be in context. All right, so the first thing, since we're talking about random variables and discrete random variables, the word random in math means something. It's not just like if I say something happens randomly, and I'm just, talking about seeing a squirrel run across the road, something like that, then that's different context. That's a different situation. When we use the word random in statistics, what we're talking about is basically that there was some probability involved. And so our official textbook definition is that a random variable is a numerical measure of the outcome of a probability experiment. And one thing to note is that this idea that we have a probability experiment means that the value is determined by chance. And so I have some sort of probability situation going on. I'm flipping a coin, rolling a die, things like that. Now, if I'm rolling a die, it's very easy to see what the numerical measure would probably be. If I'm rolling a 6-sided die, then I would have outcomes 1, 2, 3, 4, 5, or 6. Then that's fine. But what about if I'm flipping a coin and I have heads and tails? Well, H and T, those are not numerical outcomes. There's not a numerical measure. And so this random variable, a lot of times we'll use an X, and we actually use a capital X. And so I might say for heads or tails, I might let X be the number of heads. So if I flip a coin once, if I have one flip, then I could have 0 heads, or I could have 1 head, right? if X is my number of heads. If I have 2 flips, well, I've got a different situation. I'm actually going to do this in horizontal simply because I'm out of room. So if I have 2 flips of a coin, I could get 0 heads. I could have 1 head, right? One could be heads, one could be tails. Or I could have 2 heads, right? They could both land on heads. So I have different numerical measures now for the outcome of a probability of experiment. So my experiment is flipping a coin, or flipping 2 coins, or flipping 15 coins if I wanted to. I would be crazy, but we could do it. So that's what we mean when we say random in probability. I mentioned earlier that we would see discrete and continuous again, but they're going to be a little bit different. So before, when we talked about discrete data from chapter 1, we said that was data that had to be whole numbers, or we talked about how they were counts. We were counting things when we were talking about discrete data. And continuous data those were things that we were measuring. And of course, decimals. We aren't always seeing them, but decimals are possible. And I'll abbreviate that. So we had things that we talked about specifically, like age. Normally when I tell someone my age, I just tell them that I am 40 years old. I turned 40 in September. So I'm actually 40 years and 1 month old. So 1/12. So I could say that, but I don't because that just is excessive, right? But that's something that has a whole number but is actually continuous. We have a different situation now. So now, when we talk about a discrete variable, we're not necessarily talking about the possible values of this x. Remember that our random variable x is something. So let me put that up here. So random variable x. So for a discrete random variable, I could have x equals lottery winnings. And, you could lose $3 because, or let's say it's probably not $3 exactly, is it? I don't know if you pay tax or not. Kind of is a tax, right? Because the money, a lot of it goes to the state. But let's say, $3.95 is the cost of a ticket. Well, you could lose that. You could just not win. And then you've spent money. And we're going to say net. You could win $5. Well, but if you win $5 and you spent $3.95, well, you gained $1.05. Or maybe you win the jackpot and it's $1,000, but of course you're not really winning $1,000 because you spent $3.95. It would be $996.05. Right? Yes, $4 and a nickel. So there we go. And so, whatever the probabilities would be down here. We'll talk about that in a minute. But this would actually be a discrete random variable. It's discrete because there are 3 possible outcomes. So that 3 is the discrete part. So hopefully that makes sense. A discrete random variable has a set number of variables. Not that you can't have a decimal as your x value. So whatever your random variable is, your variable could be anything. Now, that said, so let's see here. Let me see if I can make this so I can fit one more thing. So I'm going to make it a little bit smaller so that I can write continuous. A continuous random variable, on the other hand, has an infinite number of possible values for the x. So let's say I let x equal the height of a basketball player. Or any height. It doesn't have to be basketball player. I just decided to pick basketball player. It could be the height of young women between 20 and 30. I don't know, anything. But the height, so there's not just 5'1", 5'2", 5'3". Height is a measurement. If we were truly measuring these basketball players' heights, and we were getting a precise measurement, I don't know, to maybe the nearest 16th of an inch, we have a laser measure or something like that, then this would be a continuous scale. And so there would be an infinite number of possible x values, and we couldn't just list them out like we were able to up here. So that's our discrete versus continuous. Now, bonus for right now, we're only focusing on discrete in chapter 6. We'll talk about continuous in chapter 7, which will be a different video. So I mentioned on the ESOLIN's page that this idea of expected value, what's expected to happen, is really just a contextualized version of the mean. So whenever we see expected value, that's simply the mean outcome. Now, we've been finding the mean so far by adding everything up and dividing by however many outcomes we have. Well, that, if you think back to chapter 5, when we talked about our different types of probability, that would be for our empirical probability, where we have actual data. Now we need to figure out a way to find out what the expected value would be for theoretical probabilities. And so we have a way to do that. But we call it our expected value. So, for example, just without even having to have a formula or an idea of what we would need to do for it, I bet we can figure out some expected values or means for some probability situations. So, if I were to flip a coin 10 times, how many times would you expect that coin to land on heads? Well, of course, if you just think in general, what do we expect happens when we flip a coin? We expect about half of the time that it'll land on heads, assuming it's not a trick coin, a weighted coin. A weighted coin means that it's weighted to where it will land on one side more frequently than the other. And so, out of 10 times, we would expect 5 heads. Just half of them. Same thing if I were to roll a die. Now, if I was rolling a 6-sided die So, I've got 1, 2, 3, 4, 5, or 6 as my options. If I were to roll one of those 30 times, how many times would you expect the die to land on a 4? Well, a 4 is one of the 6 options. And again, as long as this isn't a weighted die, and I wish we were in class because I actually have some dice that have weights in them, and they land much more frequently on one number than another. But we won't get to experiment with those. But as long as this is a fair die, and I'm rolling it 30 times, then I would expect about a sixth of the time for it to land on a 4. And 1/6 of 30, well, that's 5 times that I'm expecting it to land on a 4. So that's my expected value, which is also my mean.